Gosh darn it, why can't I make the goal? I wish I had some sports scientists who specialise in biomechanics to help me out.
Did someone say they needed sports scientists?
What a coincidence! I did!
Looks like you might need some help with
Projectile motion!
A projectile is a body in free fall affected by gravity and air resistance. Therefore, projectile motion is the movement undertaken by the projectile.
Does that mean this ball's a projectile?
That's right, and there are multiple factors that affect its flight path.
The three factors that affect projectile motion are height, angle, and velocity of release.
The height of release is the point at which the ball is released relative to the ground. The relative projection height is the difference between the release height and the height of the target. A netball pass has a relative projection height of approximately 0 as it is released at the same height as the target, as seen here. However, a netball shot has a relative projection height of approximately -1 metre, depending on the height of the player, as the ball is released from a lower height than the target, being the rim. If the angle and velocity of release are kept constant, an increase in release height will increase the total horizontal displacement, as it increases flight time.
So you're saying that the ball will be in the air longer if I throw from my head instead of from a chest pass?
Yeah, that's right.
Oh cool, that makes so much sense. But what about this angle of release you mentioned?
Well, Nathan can help you with that.
Ah! Where were we? So, the angle of release of a projectile is the angle relative to the horizontal at which it is released. It affects flight time, vertical height, and horizontal distance travelled. The optimal angle of release varies based on height of release and height of the target. For a projectile landing at the same height as release, the optimal angle is 45 degrees. For example, when you are passing the ball a long distance. However, when shooting, the optimal angle is much larger as the target height is above the height of release. Flight time is also related to the angle of release. The lower the angle of release, the smaller the flight time. To avoid an interception, a pass must be passed quickly in netball. This can be done through using a chest pass with a small angle of release.
So now I know what angle to throw the ball at, but how hard should I throw the ball?
Velocity of release is the speed at which the ball is travelling immediately after release. This can be broken down into two components, the vertical and the horizontal velocity. As you can see here, when throwing or shooting the ball with a higher angle of release, the vertical component is higher, whereas when passing or shooting lower, the horizontal velocity is higher. The vertical velocity is affected by gravity, causing the acceleration of 9.81 meters per second squared downwards. The horizontal velocity is not impacted by gravity, and therefore horizontal velocity, as you can see here, is often considered constant throughout a projectile's flight path.
But if I want to figure out what angle, velocity or height to use, how do I work it out?
We can all help you out with that.
There are three equations used in projectile motion to calculate variables of interest in a projectile's flight path. The three equations each contain different variables and can be used in different circumstances to calculate the desired variable. These formulas are known as the equations of motion.
The first equation is Vf equals Vi plus At, where Vf equals final velocity, Vi equals initial velocity, A equals acceleration, and T equals time.
The second equation is Vf squared is equal to Vi squared plus 2Ad, where Vf is the final velocity, Vi is the initial velocity, A is acceleration, and D is displacement.
The third equation is D equals VIT plus half AT squared, where D equals displacement, Vi equals initial velocity, T equals time, and A equals acceleration.
So if I understand correctly, when passing the ball a longer distance, I want to release the ball from a greater vertical height with a larger angle of release. And for a short pass, I want to release the ball from a lower height with a smaller angle?
Yeah, that's right.
And then when I shoot the ball, I need to release the ball at a much larger angle of release as the landing height is above the height of release?
Yeah, that's it.
So combining this with the speed of release, the faster I throw the ball, the higher and further it'll go. And when passing, I want to throw the ball much faster with a smaller angle of release to reduce the flight time.
Perfect.
And then finally, to work out what specific height, angle and velocity I need for passing or shooting, I can use the three equations.
Wicked, now go out there and give it your best shot.
Yes! Those sports scientists really know their projectile motion.